Hello friends, in previous three videos we discussed problems based on locus. As I said earlier, locus is the most important part of the coordinate geometry. Let's discuss some more trends. Question is if line x over a plus y over b is equal to 1 moves in such a way that 1 upon a square plus 1 upon b square is equal to 1 upon c square, where c is constant. Here a and b are variables, so this line is variable. Okay. Then prove that locus of the foot of perpendicular from origin upon this straight line is curve x square plus y square is equal to c square. Now here we have two variables a and b. So to get the locus of the required point, we will eliminate variables a and b. अगर क्वेश्चन में कुछ वेरिएबल्स गिवन है तो हम क्या करते हैं, उन वेरिएबल्स को एलिमिनेट करते हैं. ठीक है ना. Now let's draw this line for some set of values of a and b. We have this line like this. Okay, this is a straight line x over a plus y over b is equal to 1. This is variable line. Okay, now on this variable line what we do, we draw perpendicular from origin. We draw perpendicular upon this straight line from origin. Okay, this is foot of perpendicular, variable foot of perpendicular. Suppose coordinates are h comma k. Okay. Now we have to find the locus of this variable foot of perpendicular. Under the condition 1 over a square plus 1 over b square is equal to 1 over c square, where c is specified constant. क्या करेंगे? Now this point lies on the straight line. It will satisfy this equation. Okay, so we have h over a plus k over b is equal to 1. ये पॉइंट इस लाइन के ऊपर है तो इसके इक्वेशन को ये सेटिस्फाई करेगा. Now these two lines are perpendicular, then product of their slopes will be -1. Now what is slope of OP? इस लाइन का स्लोप क्या होगा? Slope is k upon h, and slope of the straight line is -1 upon a over 1 upon b. Okay, this is equal to minus b upon a. Okay, so we have one more relation in h and k, that k upon h multiply by minus b over a, this is equal to -1. When two lines are perpendicular, product of their slopes is -1. Okay, from this we get bk is equal to ah, or h upon b minus k over a, this is equal to 0. ठीक है ना, हम इसको इस तरह से लिख सकते हैं. This is equation number 1, this is equation number 2. Now we have to eliminate a and b. We have three equations in a and b, this and this given equation. ठीक है, कैसे eliminate करेंगे a and b को? Here we have h upon a, here we have h upon b, here we have k upon b, here we have k upon a. Okay, so what can we do? We can simply square and add. When we square and add, we will have expression here 1 over a square plus 1 over b square, value of which is 1 over c square. Now elimination method or process depends upon what kind of equations we have. ठीक है ना, हर एक क्वेश्चन में एलिमिनेशन का तरीका अलग अलग होता है. वो डिपेंड करता है कि हमारे पास किस टाइप्स के इक्वेशंस हैं. तो स्क्वायरिंग एंड एडिंग से क्या मिलेगा हमें? हमें मिलेगा एच स्क्वायर inside bracket 1 over a square plus 1 over b square plus k square inside bracket 1 over b square plus 1 over a square, this is equal to 1, and this value is 1 upon c square. So we get h square plus k square is equal to c square. Then finally we replace h by x, k by y. We get equation of locus as x square प्लस वाई स्क्वायर इज इक्वल टू सी स्क्वायर. ठीक है ना, तो ये सॉल्यूशन बहुत सिंपल है, पर ये सिंपल इसलिए है क्योंकि हमने इसको हैंडल इस तरह से किया है. ठीक है ना, लेट्स ट्राई नेक्स्ट क्वेश्चन देन. ओके, नाउ लुक एट दिस वन. Given point A having coordinates 1, 1 and AB is any line through it cutting the x-axis at point B. If AC is perpendicular to AB and meets the y-axis at C, then find the locus of midpoint of BC. Let's draw the diagram. We have here coordinate plane. We have variable lines passing through point A having coordinates 1, 1. Let's draw one such line. This is a line through point A having coordinates 1, 1. We can draw infinite number of lines through point A. This is one of those infinite lines. Okay. Now this line meets x-axis at point B. Here point B is variable because this line is variable. Okay. Now AC is perpendicular to AB, meets y-axis at point C. So we draw line perpendicular to AB through point A. We have this line. Okay. This line meets y-axis at point C. Then we have to find the locus of midpoint of BC. हमें BC के midpoint का locus निकालना है. So we joined points B and C. Its midpoint is D, suppose. Okay. Let coordinates are h, k. हमें point D का locus निकालना है जो BC का midpoint है. हमें h and k के बीच में relation निकालना है. We start with point D. D is midpoint of BC. So coordinates of point B are 2h, 0 and those of C are 0, 2k. ठीक है ना? D midpoint है BC का तो B and C के coordinates आसानी से आ जाएंगे क्योंकि ये points coordinate axis के ऊपर है. ठीक है ना? Now this line is perpendicular to this line. When two lines are perpendicular, product of their slopes is -1. Okay. So we have here slope of AB multiplied by slope of AC is equal to -1. Slope of AB is 1 minus 0 over 1 minus 2h multiplied by slope of AC is 1 minus 2k over 1 minus 0. This product is -1. Okay. From this we get 1 minus 2k is equal to 2h minus 1 or h plus k is equal to 1. Replace h by x, k by y. We get locus as x plus y is equal to 1. So this is locus of midpoint of BC. ठीक है ना? So here what is the strategy to solve the question? We started with the point whose locus is to be found out. Coordinates are suppose h, k. We got the coordinates of points B and C because D is midpoint of BC, and we got the coordinates in the form of h and k only because these 2 points lie on the coordinate axis. Then we use the condition given in the equation that these 2 lines are perpendicular. We translated this condition into the mathematical equation that product of slopes of 2 straight lines is -1. Okay, and we got the equation of locus. Let's do the next question. Okay, now let's solve this question. A line segment of fixed length 2 units moves so that its ends are on the positive x-axis and on the part of the line x plus y is equal to 0 which lies in the second quadrant. Then find the locus of the midpoint of the line segment. Here we have line x plus y is equal to 0. You know that this line is a bisector of second and fourth quadrant. It passes through origin. Okay. So first let's draw this line. We have this line x plus y is equal to 0. Okay. Let's extend a bit. Okay. Now we have a line segment of fixed length 2 units. It moves so that ends are on the positive x-axis and on the part of this straight line which lies in the second quadrant. तो हम यहाँ पे एक लाइन सेगमेंट ड्रॉ करते हैं जिसका लेंथ 2 यूनिट्स है. ठीक है. इसका एक एंड एक्स एक्सिस के ऊपर है और दूसरा एंड इस लाइन के ऊपर है, और ये जो पॉइंट है ये सेकंड क्वाड्रेंट में है, ठीक है ना। Suppose this is point A, this is point B. Here points A and B are variable points, but length AB is 2 unit. Here AB is 2 units. This is given. Then we have to find locus of midpoint of AB. Suppose midpoint C. Coordinates are suppose h comma k. हमें point C का locus निकालना है. That means we have to get the relation between variables h and k. कैसे निकालेंगे? Now, what will be coordinates of point B? Here point B is variable which lies on this straight line. Okay. Suppose FC size alpha, then ordinate will be minus alpha. ठीक है ना? If you put here x is equal to alpha, we get y is equal to minus alpha. Now C is midpoint of AB and ordinate of A is 0. हम उसी का फायदा उठाएंगे. So we have minus alpha plus 0 upon 2 is equal to k, or value of alpha is equal to minus 2k. ठीक है ना? So we have here ordinate of point B which is 2k, then abscissa will be minus 2k. ठीक है ना? ठीक है, समझ में आ रहा है? Okay. Now we have coordinates of B in the form of h and k, in fact only k. Now AB is 2 units, so BC will be 1 unit because C is midpoint of AB. So we have BC square is equal to 1. Now we can use a distance formula. So we have h plus 2k whole square plus 2k minus k, k. So we have here k square. This is equal to 1. Okay. So we have here h square plus 5k square plus 4hk minus 1 is equal to 0. Now replace h and k by x and y. We get equation of locus as x square plus 5y square plus 4xy minus 1 is equal to 0. ठीक है ना? So here again we started with point C whose locus is to be found out. हमने उस पॉइंट से स्टार्ट किया जिसका लोकस निकालना है और उसी को यूज करके हमने ये सारे पॉइंट्स निकाले. कंडीशन यूज किया जो क्वेश्चन में गिवन है दैट ए बी इज हैविंग लेंथ 2 यूनिट्स. ओके, और हमें पॉइंट सी का लोकस मिल गया. आगे बढ़ते हैं, एक और क्वेश्चन ट्राई करते हैं. Okay, now we have some questions based on locus of centers of triangle like centroid, incenter, circumcenter, orthocenter. We have done many questions in previous videos. Okay, we have some more questions here. Let's see this question. Line L1 having equation 4x plus 3y minus 12 is equal to 0 meets axis at points A and B. Now variable line perpendicular to L1 meets axis at points P and Q. Then find the locus of circumcenter of triangle ABQ. Let's draw the diagram. We have here coordinate plane. Line L1 is this. X-intercept is 3, y-intercept is 4. So let's draw the line. We have this line. This is point A having coordinates 3, 0. This is point B having coordinates 0, 4. Okay. Now what do? We draw one variable line perpendicular to L1. We can draw infinite number of lines which are perpendicular to this straight line. Okay. This is one such line. Okay. Now this line meets axis at points P and Q. Here the points are A and B, here points are P and Q. We are taking these points in order. First point is on x-axis and second point is on y-axis, like that. Okay. Now we have to find locus of circumcenter of triangle ABQ. Let's join points A and Q. We have triangle ABQ. Okay. In this triangle, These 2 points are fixed, these two vertices are fixed. A and B जो है वो fixed vertices है. Vertex Q is variable vertex. In that case, we have to find the locus of circumcenter of triangle uh, AQB. ठीक है ना? Now suppose circumcenter has coordinates h comma k. Circumcenter is suppose C having coordinates h comma k. Now we know that circumcenter is equidistant from all the three vertices of triangle. ठीक है ना? So we have AC is equal to BC. So we have AC square is equal to BC square. Now AC square is h minus 3 whole square plus k square, and BC square is h square plus k minus 4 whole square. ठीक है? We can say that circumcenter will lie on the perpendicular bisector of line segment AB or side AB. ठीक है ना? Circumcenter is a point of concurrency of perpendicular bisectors of sides of triangle. Here side AB is fixed. ठीक है? Points A and B जो हैं वो fixed points हैं. So for variable triangle ABQ, circumcenter will always lie on the perpendicular bisector of AB. So we will get the equation of locus, which is actually परपेंडिकुलर बाइसेक्टर ऑफ ए बी. ठीक है ना? तो ये जो इक्वेशन है वो स्ट्रेट लाइन होगा जो एक्चुअली ए बी का परपेंडिकुलर बाइसेक्टर होगा. ठीक है ना? सो इक्वेशन ऑफ लोकस इज नाउ फ्रॉम बोथ साइड्स h square and k square get cancel out. So equation is minus 6h plus 8k 9 minus 16 minus 7. This is equal to 0. Replace h and k by x and y. So required equation of locus is 6x minus 8y plus 7 is equal to 0. ठीक है ना? ये AB का परपेंडिकुलर बाइसेक्टर होगा. ठीक है ना? ये AB के मिड पॉइंट से पास होगा. आप चेक कर सकते हो AB का मिड पॉइंट क्या होगा? 3/2, 2. ठीक है ना? Now this line will satisfy these coordinates. So we have here 6 multiplied by 3/2 minus 8 multiplied by 2 plus 7. You can check. This is 9, 9 plus 7, 16, 16 minus 16, 0. So it is verified. ठीक है ना? Let's do one more question then. Okay, now for next question, we draw the diagram. We have one line segment of fixed length C units such that its ends are touching positive x-axis and positive y-axis. Suppose this is point A, this is point B. Points A and B are variable points because this line segment is sliding between these two coordinate axes on positive coordinate axis. Length AB is C units. Okay. Now we draw rectangle OAPB. हम एक rectangle draw करते हैं OAPB. This rectangle is variable because A and B are variable, so point P is also variable. Now from point P, we draw perpendicular on line segment AB. Suppose this is foot of perpendicular D, then we have to find the locus of this foot of perpendicular. पॉइंट P से हम AB को परपेंडिकुलर ड्रॉ कर रहे हैं और हमें इस फुट ऑफ परपेंडिकुलर का लोकस निकालना है. Now in many questions of locus, some variable is given. To get the locus of required point, we eliminate that variable. But here we don't have any variable. Okay, so what we do? We introduce one variable and then eliminate that variable. Suppose this angle is alpha. This angle alpha is variable. Now AB is C units. Okay, so in triangle AOB, in this right angle triangle, OA is C cos alpha and OB is C sin alpha. So coordinates of point P are C cos alpha comma C sin alpha. Its coordinates are variables because angle alpha is variable. Now we will try to get coordinates of point D as a function of angle alpha. For that what we do, we draw perpendiculars from point D upon axis. Okay, this is point M, this is point N. Okay, to get the coordinates of point D, we find OM and ON. हम trigonometry use कर सकते हैं यहाँ पे. This angle is alpha, so this angle will be 90 minus alpha. Okay. Now in right angle triangle ADP, we have AD is equal to hypotenuse, which is C sine alpha multiplied by cos of this angle. This angle is 90 minus alpha. This is sine alpha. So AD is equal to C sine square alpha. ठीक है ना यहाँ तक? Now we have AD. So to get DM, we consider right angle triangle AMD. In right angle triangle AMD, we have sine alpha is equal to MD, this height upon hypotenuse. Hypotenuse is C sine square alpha. So we have MD is equal to C sine cube alpha. ठीक है ना? So ordinate of point D is C sine cube alpha. Suppose this is Y. ठीक है ना? Now we have to get the abscissa of point D. For that we try to find length ND. कैसे निकालेंगे length ND? Now AB is C units, AD is a C sine square alpha units. So BD is equal to C minus C sine square alpha. This is equal to C cos square alpha units. ठीक है ना? Now this angle is alpha. Okay. So in right angle triangle B and D, we have cos alpha is equal to adjacent side ND upon hypotenuse C cos square alpha. So ND is C cos cube alpha. Suppose this is X. Now we have coordinates of point D as a function of angle alpha. Okay. Now we can easily eliminate alpha. We have a value of cos alpha as x upon c power 1 upon 3 and value of sine alpha as y upon c power 1 upon 3. ठीक है ना? Now we can eliminate alpha by squaring and adding. So by squaring and adding we get equation of locus as x upon c power 2 upon 3 plus y over c power 2 upon 3 is equal to 1, or x power 2 upon 3 plus y power 2 upon 3 is equal to c power 2 upon 3. This is equation of locus of foot of perpendicular from point P upon लाइन सेगमेंट ए बी. तो हम यहाँ पे ट्रिगोनोमेट्री का भरपूर यूज कर रहे हैं. हम ट्रिगोनोमेट्री को अच्छे से काम पे लगा रहे हैं. ठीक है ना? यही तो मजा है क्वेश्चन में. यहाँ पे स्ट्रेट लाइन के इक्वेशंस तो इनफैक्ट इन्वॉल्व हो ही नहीं रहे. वी आर नॉट इन्वॉल्विंग इक्वेशंस ऑफ स्ट्रेट लाइन. वी आर यूजिंग सिंपल कोऑर्डिनेट ज्योमेट्री एंड सिंपल ट्रिगोनोमेट्री. ओके, लेट्स डू नेक्स्ट क्वेश्चन. Okay, now we have this question for you. A rectangle PQRS has its sides PQ parallel to the line y is equal to mx, and vertices P, Q and S lie on the lines y is equal to a, x is equal to b and x is equal to minus b respectively. Then find the locus of vertex R. Let's draw the diagram. We have here coordinate plane. Let's draw the lines. X is equal to b, x is equal to minus b and y is equal to a. Lines draw करते हैं ये. We have here line x is equal to b. Then we have here line x is equal to minus b. Then we have line y is equal to a this is line y is equal to a. Okay, now let's draw the rectangle. We have this rectangle. We have point P on line y is equal to a, point Q on line x is equal to b, s on line x is equal to minus b, and here we have vertex r. Suppose coordinates are h comma k, we have to get the locus of this variable point r. In fact, all these points are variable. We have to get the locus of vertex r. Now we have to get the relation between variables h and k. Okay. Now here geometrical figure rectangle is involved. So we must use the properties of rectangle so that we can confirm that PQRS is rectangle. हम रेक्टेंगल की प्रॉपर्टीज यूज करेंगे जिससे ये कंफर्म हो जाए कि PQRS रेक्टेंगल है. ठीक है ना. Now rectangle is parallelogram. In parallelogram diagonals bisect, the midpoints of diagonals coincide. But this is for parallelogram. But for rectangle we require one more condition, and that is two adjacent sides are perpendicular. ठीक है. If two adjacent sides are perpendicular and diagonals bisect, then geometrical figure is rectangle. अगर हम इसको use कर लेते हैं तो equation definitely solve होना है. ठीक है ना. Now let's set the coordinates of P, Q and S. Coordinate of point P is A because this point lies on line y is equal to A. Suppose abscissa is alpha. Okay. Abscissa of point Q is B. Suppose ordinate is beta. Abscissa of point S is minus b. Suppose ordinate is gamma. Here we have three variables alpha, beta, gamma. We will try to eliminate these three variables. Okay. Now diagonals bisect. Okay. We have here diagonals PR and SQ. So we have H plus alpha upon 2 abscissa of midpoint of PR is equal to abscissa of midpoint of QS. Abscissa is 0, B minus B is 0. So from this we get alpha is equal to minus h. Okay, तो हम यहाँ पे alpha की value put करते हैं. This is minus h. Now we have only two variables beta and gamma. ठीक है ना. Now we have ordinate of PR a plus k upon 2. This is equal to ordinate of QS, which is beta plus gamma upon 2. So we have one equation in beta and gamma. Beta plus gamma is equal to a plus k. ठीक है ना यहाँ पे. Now this is for parallelogram, that diagonals bisect. Now for rectangle, PS is perpendicular to PQ. It is given that PQ is parallel to the line y is equal to mx. So slope of PQ is m, then slope of PS must be minus 1 upon m for PQRS to be rectangle. It is already parallelogram with this condition, and for rectangle we have here slopes m and minus 1 upon m. Okay, so we have slope of PQ m is equal to, PQ का slope क्या होगा? Slope होगा बीटा माइनस a upon b plus h, and slope of PS minus 1 upon m is equal to, slope will be gamma minus a upon minus b plus h. ठीक है ना. Now from this we get the value of beta, and from this we get the value of gamma. Value of beta from here is bm plus hm plus a. Okay, and from this equation we have gamma is equal to b minus h over m plus a. With this values of beta and gamma in this equation, we get equation in variables h and k, then replace h by x and k by y to get the equation of locus of vertex r. ठीक है ना. तो यहाँ पे हम ज्योमेट्रिकल फिगर रेक्टेंगल के लिए कंडीशंस यूज कर रहे हैं, that diagonals bisect and adjacent sides are perpendicular.